equation. Let's balance and indicate the states of matter. Get ready to calculate moles of reactants. Draw 3 lines before you start.
To start the process, convert mass in grams to moles. The coefficient will tell you the ratio.
Let's convert the grams tonight into moles, then back calculate until we die, you and I. Chemistry forever. You make me feel like I'm learning stoichiometry, though balancing equations. Now we'll make products equal reactants, equal reactants.
Look at reactants and find out which limiting. Divide the moles by coefficients.
Terrible, terrible, terrible. Let's just go to Calvin and his cooking time to explain this concept.
Thank you! Welcome to Cooking Time with Calvin Walker. To illustrate what a limiting reactant is, we're making lemonade. And here we have excess water and our lemon. But we only have a little bit of lemon, so it is our limiting reactant. So if we were to put this in here, there would be water left over because the reaction would not be complete. But if we pour it into here, I've already calculated, so we have the proper ratio of lemon and water. So now, both of the products are used up in the reaction, so we have delicious lemonade. Put that in your glass and drink it.
Human stoichiometry using conversions, calculating quantities. Avogadro's number is 6.02 times 10 to the 23.
Yeah, okay. Yeah, okay. Yeah, okay.
I like all.
Yeah, okay.
I like all.
Valerie actually said.
We came in here to learn. Draw 3 lines, take a turn. Put on top balanced equations, moles and mass, all situations. So come on, let's go. Let's lose those grams. Divide mole and mass until the moles are in hand. Keep converting back and forth. Just remember grams point north. We gon' calculate it all. Chemistry won't be our downfall. Just find limiting. Then calculate weight. Convert mass to moles till you got the answer.
Hello, and welcome to Chemistry with Cameron. Our reaction today is H2 plus O2 becomes H2O. What we are looking for is the limiting reactant when given 3 grams of H2 and 1 mole of O2. We're looking for the theoretical yield of H2O, and we're looking for the percent yield of H2O. So let's move over here to where I've rewritten the reaction. What we are supposed to do to balance the equation is make sure I have rewritten the reaction right here. First we need to balance the equation. We have 2 hydrogens and 2 oxygens on the left side, and 2 hydrogens and 1 oxygen on the right side. We need the amount of reactants to equal the amount of products. So first what we need to do is put a 2 in front of the H2O, which gives us an even number of oxygens on the right and the same number of oxygens on the left. But now we have 4 hydrogens on the right and only 2 hydrogens on the left. So we need to put a 2 in front of the H2, and the equation is balanced. Next, we need to write the states of matter of each part of the reaction. We know that H2 is obviously a gas. O2 is also obviously a gas. And H2O is obviously liquid. So there you have it. Now we're going to draw 3 lines, because this is a stoichiometry equation. We've been given 3 grams of H2 and 1 mole of O2. So we have 3 grams of H2 and 1 mole of O2. The top line, obviously, is going to be the reaction. The middle line is moles, and the bottom line is grams. That was a door slam. Okay, continuing. So first we need to get from grams to moles. We know that there's 3 grams of H2. We have 3 grams of H2. To find the amount of moles, we need to take grams over molar mass. We know that the molar mass of H2 is 2 grams. So 3 divided by 2 is 1.5. Now we need to find the limiting reactant. To find limiting reactant, we take the amount of moles over the coefficients. So for H2, it's 1.5 divided by 2, which gives us 0.75. For O2, it's 1 divided by 1, which gives us 1. The limiting reactant is the one with the lesser percent, and in this case, that's H2. So know that H2 is going to be the limiting reactant with 1.5 moles. What that basically means is that H2 is going to be limiting the amount of product that this reaction can make, because there's an excess of O2. So now we need to find the theoretical yield of H2O. To find the theoretical yield, we just have to get from 1.5 moles of H2 to X amount of moles of H2O. So we're going to take 1.5 moles H2. There's 1.5 moles of H2 for every 2 moles of H2. And we know that there's 2 moles of H2O for every 2 moles of H2. So that leaves us with 1.5 moles of H2O. Which gives us the theoretical yield. So now that we've calculated that, we need to find the experimental yield. So let's say that we've already done the experiment. So given the number of moles of H2O, we need to find the amount of grams of H2O created. So to find that, we take 1.5 moles multiplied by the molar mass of H2O, which is, this is about 2, this is about 16, so that's 18. So 1.5 times 18, which gives us approximately 27 grams.
Wait! I did this experiment and I only got 19 grams. What's up with that?
I don't know.
Well, I'll explain.
Good.
We're finding the percent yield. So if I got 19, and this is the theoretical yield, which is 27, we do 19 divided by 27, and you get 70.3. So the percent yield in this reaction is 70.3%. Because it is the actual yield divided by the theoretical yield.
Amazing.
You make me feel like I'm learning stoichiometry, the way we're balancing equations. Now we'll make products equal reactants, equal reactants.